And always keep the three main trig definitions handy to refer to. And those are the following. The sine of an angle, we'll call it theta, unknown angle, is always going to be the opposite over the hypotenuse. The definition for the cosine of an angle will always be the adjacent over the hypotenuse. And finally, the tangent of an angle will be defined as the opposite side over the adjacent side. All right, so let's keep these handy when we're doing our problems. Also, when we're doing problems, you may know the sine and the cosine. In order to find the tangent, if they give you sine and cosine and they ask to find tangent, one definition that I haven't given you yet for tangent is thus. If you know the sine and cosine, you can find the tangent directly by using this equation. Very important that you know this. So I'm gonna mark this as 3 alternate for tangent. There it is. 3 alternate definition for tangent is going to be the sine of the angle over the cosine of the angle. So if they ask you for the tangent of an angle and you know it's sine and cosine, you can find the tangent by plugging in the sine value at that angle over the cosine of that angle and then reducing the fraction. Okay? And I'm going to show you now why that works. Here's why it works. All right? The tangent of an angle, if we have the sine in the numerator, if I plug in the definition of sine in the numerator, so that's going to be the opposite over the hypotenuse. And that's the sine, that takes care of this top part right here, over the cosine. And if I plug in the definition of the cosine right here, so that's going to be the adjacent over the hypotenuse. Okay? Now this fraction can be reduced. Anytime you have a fraction in a fraction, and in this case we have a fraction in both the numerator and denominator, whenever you have a fraction in a fraction, you always can reduce that by taking the reciprocal of the denominator. So in this case, here's your denominator. Its reciprocal will be hypotenuse over adjacent. Okay, and I'm going to take the reciprocal of the denominator and I'm going to place it right next to it. I'm going to make a little construct right next to it, and I'm going to take its reciprocal and place it right here, hypotenuse over the adjacent, and then I'm going to take this and copy it over itself, because anything over itself is equal to 1. So I'm going to copy the denominator over itself. Okay? And now I'm going to multiply my first original equation times this construct whose value is 1. And we can multiply anything by 1 without altering its value. Now, whenever you multiply a fraction times its reciprocal, we're always going to get a 1 down below here. So this will cancel with this, and we'll end up with a 1 right there. All right? Again, Any fraction times its reciprocal is automatically equal to 1. Now, up top, when I multiply these two fractions times each other, can anybody see what can I cancel between the numerator and denominator? Anybody? James?
You can cancel the hypotenuse from the top of the right and the bottom of the left.
Very good. Yeah, I can cancel these hypotenuses. Anything over itself is 1. Now I'm left with the opposite over the adjacent. Opposite over adjacent. Okay? And anything over 1 is itself. So here's our answer. So this shows us that the tangent of theta reduces down using sine over cosine, reduces down to opposite over adjacent, which is the definition of tangent. So this is equivalent to this. All right? So if you're given the sine and the cosine and you're asked to find a tangent, you're going to use this 3 alternate formula right here. Okay? Thank you.